Hello, folks. Welcome to Rational Science. Today I'm not feeling good again. I'm having problems with my chest. Uh, I have to breathe deeply. I don't know why. I go to the hospital, go to the doctor, and they tell me, "You're okay, Bill. Pressure's good, heart is good, blood is good." And it's like, you go to the doctor and you tell them, "I don't feel good, doctor." "No, you feel okay. Go home." You end up in the morgue. Or you go to the doctor and you say, I'm doing fine. I'm doing okay." And he says, "No, no, you got to take this pill." Why? I'm doing okay. Well, because the people who want me to peddle this pill says that it's good for you. So, you wonder about all these witch doctors. Anyways, I had some well wishers, and I want to thank them. Okay, here's a couple of them. I pulled a few of the comments people made. And a fellow says there, "Leave carbohydrates and beers alone." Beers. He wants me to leave. Here I've been drinking a beer. I mean, if I'm going to die here on camera, I might as well, have a beer. Die with a beer in my hand. Anyways, it says concentrate on cooked and raw vegetables. A lot of people recommend that. No fruits at all. Some people do recommend fruits, others say no, okay? Careful with physical exercise, slow and well. Yeah, I do my exercise, you can see there. Uh, Always do your exercises. Uh, so, yeah, everybody's involved with this issue about, doing exercise, eating veggies, let go of the carbs, and maybe even some people say let go of the meats. Uh, Everybody's an expert today on how to be healthy. And, in my case, I'm 69, going on 100. And the issue is whether you can do miracles after a certain age. When you're 69, your life is behind you and you're talking about history. When you're 20, it's the other way around. You're looking at the future. Your life is ahead of you. And so there's different ways of looking at these things. In fact, that's, I think, has a bearing on how people visualize extinction, because the old folks like me, older folks, there's people with much older than me, and their life is really their history. They've got it all here in memory. Whereas the person who's 20 or 30 years old, he looks forward and he says, "I don't want to die. I don't want the world to end now. I want to retire, reach old age, and then die naturally or not die at all if possible. And then if extinction happens after me, I mean, I don't care." Yeah, but see, so those are two different ways of looking at this whole thing. In fact, some people said, "Bill, the reason you think about extinction is because you're about to die." And yeah, it could be true. I'm not saying it's not true. I'm looking at the mechanism. Okay, I'm saying what the mechanism of extinction is. I'm not worried about when it's going to happen. Okay. Well, another fellow said here. Yes, may I advise that you look into having one small aspirin per day until you have more data to set on it, and pursue either coronary artery calcium or measurements so that you have actionable data to act on together with your doctor. What I can tell you is, you know, my mother always said that she didn't like doctors, and she faked just about all our vaccines. I don't even know what vaccines I got because she faked a lot of them. She did not believe in vaccines. She worked at the Swedish American Hospital as a nurse for a couple of years. Then she worked as a dentist assistant. And she thought a lot of the procedures that she saw, right, were unnecessary, that they were for profit. And so she developed a militant attitude against doctors in general. And the flip side of that is that she died because of cancer to the uterus. She died at a relatively young age of 62, and she could have lived maybe another 20 years if she would have caught it on time, knew what it was, and would have had an operation. An operation a lot of women have today, which is just get rid of the uterus and you can live a little longer. And so, you got to be careful about what decisions you take. And for me, it's a lesson. I hope you take it as a lesson. But regarding aspirin, she believed in aspirins. And one of the things I can tell you is that I believe in aspirin too. I'm a strong proponent of aspirin because, when you drink a little too much, usually that's the case when I take an aspirin, the next day, if you don't take an aspirin, you're going to feel very bad. And to help with a hangover, I usually learn from one of my buddies at work that it's good to take an aspirin at night, especially if you drink. Take an aspirin and then go to sleep. You'll wake up a lot better. And I followed his advice, and it's always worked for me. So I can recommend that. Aspirin I believe in aspirin. I don't know if I believe in the vax and the COVID, but I do believe in aspirin. Okay, so yeah, you don't have to tell me especially when I'm overdoing it with the drinks. Okay, and yeah, if I'm gonna die with a beer in my hand. Okay, you got to put those aspirin pills down with beer. Okay, fellow says, please look up coronary artery calcification score regarding your health issues. If you want to live a bit more, ditch the sugars, carbs, and get control of your insulin levels, you can look up insulin resistance, etc., etc. Yeah, one of the issues there is that today everybody is an expert in health. Okay, why? Because there's so much information out there. And a lot of it depends on what side you take. There are studies that contradict each other, or there are opinions out there. And people say, oh, they proved this. Well, the other guy proved the opposite. And so the question is, who are you going to follow? And it's whatever your original or what you already believe that takes you in one direction or the other. So I don't know. I can't tell you. I'm not an expert in health. I do have arthritis. I've had it since the age of around 38. That's when I first noticed that I had some kind of pain due to joints. And that was 31 years ago. And today, yeah, I feel a lot more pain in the muscles and the joints. I've had several operations, 3 of them on the shoulders, 2 on the knees, and so on, microsurgeries, to fix some little thing. Fortunately, we have that today. I can't imagine poor old Neanderthal when he had arthritis. He had to die with it. But today you can do a little bit about that with some operations. And people say, well, you didn't need that operation. You could have done this, this, and that. Yeah, I mean, at one point in time, I couldn't, do the Hitler salute. I couldn't raise my arm because my arm just hurt so much. And they did the operation. A few months later, I was okay. So I don't know what to tell you. It's like, thank God we live in this day and age where they cure these problems, but I'm not an expert on the issue. Okay, another subject matter that came out this week. Ocean City topless ordinance head to the Supreme Court, the latest legal battle. The women want to take it off. Okay? They want to show their breasts just like men do. And I'm all for it. In fact, I think it should be mandatory. All women should be topless and at the beach, okay, and maybe even bottomless. I mean, it's up to them. I have no problem with it one way or another. Of course, my wife will blacken my eyes if she sees me watching or staring at one of them. But yeah, women try to imitate men in this day and age. A lot of them think it's a question of rights. And men kind of look at that in a different way. They say, yeah, sure, go ahead, show whatever you got. Of course, if the woman is 100 years old, you may not want to watch, But, so everybody has their own vision on this. Okay, we'll see what the Supreme Court decides. Anyway, another matter. Russia vetoes UN resolution on climate change as global security threat. And I think you should keep this in mind because, for those of you who believe in conspiracies and so on, that the rich are governing the poor and so on, corralling them and, manipulating them and so on. Here you have Mr. Putin, and he thinks that this is something that favors the United States. That's got nothing to do with the climate, and it's got nothing to do with security threat, global security threat. They think it's got to do with business, and that the United States is trying to take advantage of that somehow, and creating this hullabaloo about, oh, climate change, we got to fix it because otherwise we're going to die. And my version on that is that climate change is so slow, we'll never get to it. Does climate change? Yeah, it's always changed. Uh, 600 million years that we've been around, life has been around. Um, it's climate has changed every day of our lives, of in life's history. And does that kill us? Does that cause extinction? No, obviously not. Climate change, if anything, helps out the animals that are going to radiate in the next generation. That's when certain animals squat some niches out there and they grow big and whatever, numerous, and others that are not favored by the climate, or the plants that are favored by the climates, they stay behind. And so you have the rich and powerful, and you have the weak and sometimes numerous. So climate change does not cause extinction. And if you look at a lot of the theories of extinction that you'll read out there, they're all related to climate. Oh, it was the oxygen cycle, it was the carbon cycle, it was the nitrogen cycle. It's got nothing to do with it. Absolutely nothing to do with it. Neither climate change nor asteroids ever caused the extinction of a single species on Earth. But that's what the paleontologists believe because it happened so suddenly. They say it must have been this. Had it been a catastrophic accident. And no, Mother Nature, I believe, works in a different way, and she uses the same cookie cutter for all mass extinctions. Okay. Fellow says that all these countries that I talked about the other day, the fact that Iran, Cuba, and so on, they wouldn't go along with this COVID thing because they're enemies of the United States. And if COVID was created by the United States, or even perhaps China, right? Done by the rich to control the poor, is that what it's all about? And Isabel says, you have just missed what country like USA, Mexico, Brazil, Russia, China, what they have in common. And they say it's the international financial system. Yeah, I don't think, unless you clarify exactly what you're referring to, I don't think we can say that this this COVID thing, has to do with some kind of manipulation. At least I'm not convinced of that. You can shoot all kinds of theories out there, but I personally don't buy them. I think that there is a bug out there. Some people are probably dying as a result of that. I have no idea. I know no person that I'm in contact with, that has died. I heard by word of mouth only that someone over there died, and who knows if they died because of COVID. My brother died this year. One of them died earlier this year. He died of diabetes, and maybe the government put the record that he died because of COVID, because there's a lot of interest in that, jacking up the numbers and so on. So there's a lot of that. That's human nature to do stuff like that. Did he die of COVID? Maybe, I mean, if you look up the record, maybe that's what it says. So I wouldn't put it past them that they say, well, he died of COVID. And we know what he died of. So I don't know if they're manipulating the data or what out there. Personally, I don't care. I don't give a damn about all that stuff. I'm not into this COVID. If I got to get the vax, I get the vax only because I got to travel, and I don't care about getting it or not getting it. Either way, for me, it's the same. If I get the bug, if there is a bug and I get the bug and I die because of the bug, well, so be it. I mean, That's life, you know. Okay, here we have another fella says, the rich rule the world. It's always been like that. And he said, well, technically, there were no rich people for most of human history. Hunter-gatherer tribes don't have no filthy rich people. Aha. The communist dream is to somehow revive the social relations seen in primitive tribes. And I think the Kefal is right. You know, I pretty much subscribe to this notion. Yeah, the people in the old days, they had no rich people. I mean, hunter gatherers and so on. When we talk about rich people, we're talking about, you know, from commercial agriculture, maybe up the Neolithic, you know, up onwards. Anything beyond the Neolithic, the Paleolithic, you know, you're not talking about rich people, obviously, you know, because they had no property. Property had not been invented yet. The only property was the land that the clan hunted in. They said, this is my property, and anyone who steps over here, I'm going to kill him. He's going to be part of my food, my supper. Okay, another fellow along the same lines says, it is survival of the fittest. Always has been, always will be. The rich are just manipulating the process of natural selection. These are opinions, and the question is, you know, you can't just give an opinion. Here we try to do science. Science is about explanations, not about opinions. And so it'd be nice if you put a little more, like saying, if you don't accept natural selection, you say that never happened, I don't believe in it or whatever, fine. What do you propose in exchange? How did we get here? Why do we have all these animals? Why are some herbivores and others carnivores? And we're all mammals. You know, the cow is a mammal, the lion's a mammal, and one is a herbivore and the other one's a carnivore. You got to explain. That's the purpose of science. But to give an opinion because, you know, this is what you believe in doesn't tell us much. So, you know, it's people would like to spin their wheels. Give me a theory, something I can sink my teeth into, something that I can understand. Not that I believe, but that I understand. Okay. Okay. Along the same lines, fellow says, let me put it over here. Diversity reminds me of the democracy you refer to, an illusion, it appears to be. Yeah, democracies never happened. In fact, another fellow here says along this, or maybe I think it's the same fellow, I don't know. Never be democracy. Yeah, yeah, you know, Plato, he said that it's the rule of the mob, and he didn't like democracy. He said it was the worst form of government because you got people who have no stake in it, people who are ignorant, people who have no idea about anything, and they're going to rule. You're going to put them up there, which is more or less what Marx suggested. Marx said, hey, you know, let's put the workers up there and let them govern because it's their personal interests. I got something here. What is this? Oh. It's their personal interest. But at the same time, the question is, if the guy is an ignorant person and you have many of these people and they're all up there because they govern, they're going to rule for you, and maybe they take all these irrational decisions. And so, yeah, I think Plato's notion there was more or less correct, and it never happened. You know, we never had democracy. It's always been rule of the rich and powerful. They rule, whether for good or for bad. Will they rule any better than the masses of ignorant workers? Well, I don't know. I would say that not. I'm saying that the rich and powerful are a microcosm of the workers. They have different interests, but they are a microcosm of the population. You know, they're a segment of the population. And they say, well, I'm going to rule because I have the money, I have the power, and I'm going to do whatever I want. And so the guy rules up there, and the guy on the bottom says, well, I don't like that. You know, I want to do this other thing. Why? Because he's got a different interest. Or like Marx said, you know, it's the clashes between classes. They have different interests. And so, yeah, it's the way the world has always run, at least since the commercial agricultural revolution, Neolithic. Maybe it happened even before then. The clans were ruled by some patriarch of some kind. I'm sure it wasn't equal, fully equal. Okay. Uh, there's always been rulers and uh, slaves, serfs, obeyers, whatever you want to call them, people at the bottom. I don't think that's ever changed. Well, it says here along the same lines again. Germany tried to have their own economy and financial system free from foreign investment and tentacles. I guess he's referring to the Hitler age, 1930s, 40s. This stance and attempt at monetary independence cost 14 million massacred Germans and a mental reprogramming program that never ended. Yeah, remember a lot of this has to do with racism. Um, I'm sure that if Hitler was rise from the dead today, he would say, well, maybe it wasn't only the Jewish money that rules the world. How about the Chinese money today? They rule a lot of the world today. Maybe he would say, oh, these Orientals, and carry a war against the Chinese or whatever. A lot of it is racism because they want to get the population behind them. They know the population is separated by races and by religions and aside from differences, political differences. And so, the politicians, they take advantage of that. They steer the masses in one direction or the other based on, what people believe out there. And they say, oh, people hate blacks. Okay, we're going to talk against blacks. Oh, people hate Jews. We're going to talk about the Jews. And, oh, they hate the Orientals. Let's talk about Orientals. The Orientals are in the news quite a bit lately, and the Arabs. I mean, 50 years ago, nobody talked about the Orientals or the Arabs. They weren't powerful, but now these countries, they're started coming up. They're becoming our equals, so to speak. And so now they're in the news a little more. You have this Arab world, the Middle East there. You have the Chinese and their influence in the Eastern world. And yeah, so they're in the news now. And so if we could bring some of these people from the past, like Hitler, Mussolini, and so on, they might have a different opinion today about, oh, it's not the Jews, it's the Chinese. It's just politics. That's what it amounts to. Okay, another fellow says, oh, no, sorry, this is an article that came out. And, we were talking about the Great Reset from Klaus Schwab. And here we're talking about the Great Resignation, not the reset. Or maybe the reset is the resignation. And what is this about? Well, it's saying that a lot of people are leaving their jobs. They're abandoning their jobs. Or either they quit or they've been furloughed or whatever. And the guy doesn't want to come back. They say, look, the amount of money you're offering me, it's not enough of an incentive to get me back to work. Okay. And so these were other articles there. 4.2 million Americans quit their jobs. The industries where workers quit, the most listened to article, quit the most. So they have a list of them. And then another one, the Liberty County workers who quit feel liberated. They lost their shackles, okay? But the community discovers a powerful downside. And so they went into, here you have the picture, okay? Now hiring, okay? And the fellow says, if you walk down any sidewalk, you will see now hiring, okay? Yeah, it's a lot of people are resigning and not getting back to their jobs. And it just gives a few examples there. Restaurant, hotel, barber shop, and nightclub. And you have all these comments and statements from people. They interviewed them at these different places in this little town. And maybe you could say it's again, a microcosm of what's happening, at least in the United States, and perhaps in other countries, especially in the West. And that is that people are abandoning their jobs. They're not going back. There's like 10 million jobs available. No one's taking them. And so the question is, first of all, is this real? That's one issue. The other one is, if it is real, could it be that it's because they're not paying enough? Maybe it's a question of money. If you give me more money, I'll come back to work. If you don't, I won't. And some of the comments there, even from the managers, you'll see it says like, Target offered $15 there in the hotel group. Says Target offered $15 an hour, and we were around $10 an hour, so we couldn't compete, and so on. So maybe this is just an issue of money. Should they offer more money to these people, and maybe there won't be so many jobs available, disposable, you know? And then there's the socialism part where the government says, oh, we have this pandemic, let's give people money during the transition as a stopgap. And so they give them money, and the guy says, hey, you know, I kind of like this. I got more time, I get money. I don't think I want to go back to work. I like this life, you know. And unless they give me a little more money, maybe I won't go back to work. And while they're out there, maybe they find a different activity where they can live off of. Maybe they don't make as much money. Maybe they don't have to pay the rent because they move in with mom and pops, you know. And you get all these situations out there where people are not going back to work. And there are jobs apparently, but low-level jobs, low-paying jobs, and people are not willing to take them. So, you know, you figure out whether this is going to be a problem. And on top of that, you got inflation now that's happening. Top of that, so money is not worthless, but worth less, right? And so it's all coming together. The question is whether all of this is going to lead to a crisis where the global economy collapses. And again, I always say that the only economy that needs to fail is the United States economy, the American empire. If that economy fails, the whole world fails. You know, China can't survive, Europe can't survive, Russia can't survive. Okay, and if you add to that maybe a world war where they throw the nukes, you know, the fireworks, well, all bets are off. Then you better believe that extinction is staring us in the face. So this notion that we're going to live even 100 years, I think is far-fetched. Okay, my 5 cents worth on that. Okay, the 2 COVID shots, not enough to stop Omicron. Okay, so is this being pushed down your throat, shoved down your throat? I had to get 2 shots to be able to travel because they required 2 shots. I think it was Johnson has only 1 shot. Okay, great. But I mean, you had to get these 2 shots to be fully covered. And now they discovered, they developed in the lab, right, a new version, the Omicron. And now the 2 COVID shots are not sufficient. Now you got to get a 3rd one, maybe a 4th one. I mean, I don't know. Is this real or is this being manipulated? You know, again, those people who talk about conspiracy in this context may have a point. I'm not saying that they're right or that they're wrong. Again, I don't have enough information to decide that. But yeah, it does kind of make you wonder, you know, just they're inventing all these variants, all these strands of COVID, and now you need a new shot for this one, another one for that one, another one for that one. Sounds like a used car salesman trying to sell you something. Okay, my take on that, I don't know. Again, I can only give you my opinion and not any rational explanation for that. Well, it says, you think they can't get away with lying about something like COVID? HIV has never been proven to cause AIDS. It was a big lie which the world believed, and they got away with it. Don't tell me your opinion. Tell me your theory. Okay, so COVID did not exist. It never happened. What was it? Why were all these people in San Francisco, especially, you know, why were they getting sick? You know, their immune system failed. Too much beer. You know, you got to give me a theory. Don't tell me your opinion. I appreciate your opinion, but, you know, we want to see the meat. You know, the meat is the explanation. Try to stick to that. Paul also says, you know, narrative of super dangerous virus. Yes, this is a lie. That's an opinion. Don't tell me it's your opinion. Give me an explanation. That's what is strong here. Okay, we're doing science, folks. Okay, talking about brain size the other day. Here we have, indeed, a smartphone is more powerful than a room-sized computer from 40 years ago. Size isn't everything in neurology. Yeah, they're talking about brain size. Is brain size everything? Well, now you have a chip, that's small, can't even see it. And certainly when you look at it under the microscope, I'll tell you because I've seen millions of these, right? You look at it under the microscope, 1000x, power of 1,000 times your eyesight, and you see all the little transistors in there. Fascinating, absolutely work of art, almost as much as technology. And that little thing has more powerful than the ENIAC of the 1940s. Okay, so the first computer, was all these tubes, a little cumbersome, and they have parts of that in, I think it's in the Smithsonian. It's in one of the museums. I think it's the Smithsonian Museum. And that was the first computer. And it could calculate, like a little calculator, more or less. That's the power it had. And today you have these tiny integrated circuits, chips, and they can do billions of times the calculations that thing used to do. So size is not necessarily, what gives you brain power. But you got to consider something. Mammals that have the bigger brains versus their body, because a whale has a bigger brain than a human. Does that mean that the whale has more intelligence than a human? No, obviously we had a little different evolution. For those of you who believe in evolution, we had a different process for coming up with how we ended up. And so the whale ended up big in size, but its brain, even though it's got a brain which is commensurate with its size, which is bigger than ours, doesn't have the ability that ours has. Okay, and you can go with a dolphin and parrots and other animals which allegedly or supposedly have certain levels of intelligence above that of an ant or a starfish, right? And size is not what determines how well you calibrate things in there, calculate and so on. And I gave the example of the Neanderthals. The Neanderthals are said to have had at least as big a brain as ours. Apparently, they had a little bigger brains than our brain case, bigger than ours. Maybe they even have bigger brains than ours on the average. Did that make them more intelligent? Would they be? I mean, they obviously did not develop as much as we did in our technology and our understanding of the universe and so on. So, was that a sign of intelligence, the fact that they had a big brain case? And yeah, in general, if you look at the transition over time from assuming, right, that what was it, the old monkeys, from where we came from, they had smaller brains, and over time they got bigger and bigger, like Lucy, for example. They got bigger and bigger over time, and you say, oh yeah, the brain expanded, and that's why we became more intelligent. That could have been the history of humans, okay? But it doesn't mean that the lion, who probably had also some kind of growth from a tiny animal to the lion that it is today, also had his brain grew, but that doesn't mean that the lion, because of that, can do calculus. Okay, so again, think about all that. Brain size does not necessarily translate into more intelligence, whatever intelligence is. Okay, and then a fellow says, evolution size of human brain is an opposite. The biggest evidence that the so-called theory of evolution is fallacy. Again, don't tell me that your opinion. Give me an explanation. If evolution never happened, right? Fine. We'll accept that as an assumption. It never happened. That theory is wrong. Okay, what do you propose in exchange? How did we get here? Why are all the differences between the animals? Why are some herbivores, others carnivores? And I can go on and on and on, giving you all kinds of descriptions that you would have to explain. Okay? If it's not evolution, what is it? How did we get here? Was it God and magic wand? You got to give us an explanation. Okay? It's not enough to say, I don't believe in it. That's not a good explanation. Okay, just an opinion. And it says no direct correlation between brain size and intelligence. That's true. Okay, I'm saying that it's not necessarily that way. I think there is some correlation between brain size and intelligence, at least within humans, because again, if you take Lucy and the Homo erectus and all our ancestors out there, we have the biggest brain, and that was part of our evolution. For those of you who believe in evolution, we started out a long time ago, very small. We ended up with bigger brains. Uh, was it the brain size that made us more intelligent? Well, again, we developed things like hand-eye coordination and so on, and that made us eventually develop the brain. For those of you who believe in evolution. But if you don't accept that, well, tell me what explanation you provide. Did just God make us out of clay and say abracadabra, and we ended up with this brain, this big brain that we have today, proportional to our body? You gotta give us an explanation. Okay, so yeah, even though I would say that brain, that intelligence is not necessarily related to brain, at the same time there is a correlation there. And you would think that, at least from an evolutionary perspective, yeah, the brain has evolved together with the body. Because you could say the same thing about the body. Does body give you more strength, the fact that you're bigger? And the answer is yes. If you're a little ant, you don't have the strength, the power, the weight to push you can't push your weight around because you got no weight. On the other hand, you have, an elephant, and, he's mighty. And so did size make a difference? Well, yeah, I mean, I think it did. The whale is a big animal, and it's got this power because of its size. And so if you say, well, strength is unrelated to size, well, why do we have boxing categories or, weightlifting categories? Because apparently weight has something to do with size, and strength has something to do with size. And in the same way, you can say, that thinking, the ability to think, the reasoning power has something to do with the brain size. Would a guy that's got a peanut brain, have the same level of intelligence as a guy who's got a bigger brain? I don't know. I can only guess. Certainly the connections in there, like when you have autistic people or people with brain problems of some kind, if you look at their connections in there, the quality, it's different than that of a normal human. But at the same time, maybe they have the same size brain, or even this guy might even have a bigger brain for all we know, or a bigger brain case. So size is not necessarily a determinant, but I think it's got something to do with it to some degree, in the same way that having strength has something to do with size and with bigness. Okay, and another fellow puts his 5 cents worth there. What about the brain with most wrinkles? A wrinkled brain, old brain, I guess, right? Is that a closer definer of intelligence that we can tell physically with outsider observation? Yeah, I mean, yeah, you can come up with all scenarios. The issue you got to answer is you got to explain. Okay, that's the point. So explain why we have a bigger brain than proportional to our body than other animals, and we are more intelligent. And for that, first you got to start by defining intelligence, and that's already a monster. That already will occupy your time researching. Believe me, I did it. Not easy to figure out what intelligence is or define it, right? Fellow says, I agree with Guy McPherson, okay? Latest data indicates nearly 6 degrees C by 2100. Fossil fuels are subsidized to almost, 60 per year. Peak oil study found that the expected peak oil predicted by math 60 years ago of around 2000 with almost 2006, okay, was about 2006. Okay, civilization failed for lack of maintaining complexity. We have passed peak container traffic and complexity on the planet. Public attentions is guided to unrealistic expectations about where we are in this story. And what can I tell you? I've had a talk with Guy McPherson, and we do not see eye to eye with good old Guy. He believes that extinction will happen because of climate change, peak oil, and all that stuff that everybody throws around. And the first one that you got to think about is that the dinosaurs never used peak oil of any kind. Maybe to rub their backs. I don't know. Maybe some kind of uh, what is it? Cycad oil or something. There was no peak oil in the days of the dinosaurs, and they disappeared. No peak oil in the days of the Triassic archosaurs and so on. So peak oil is not a common denominator that Mother Nature uses to get rid of species. Maybe there's something else going on. How about food? That's what I keep saying. It's got to do something with food, not with peak oil or with climate change. What does climate change have to do with extinction? But that's what Guy believes. He believes that. He says it's, he's got this chicken little attitude saying, oh, the world's crashing, the sky's falling. And the issue there is that, yeah, the sky is falling, but, well, there's two issues. One issue, he believes there is a solution. If we just could get our act together and do something about it, the politicians. And that's what everybody out there who talks about climate change, peak oil, and all these other asteroids and whatever, that's what they all believe, that we can do something about extinction. I think I'm the only person on planet Earth says we can't do anything at all about extinction. Extinction is a done deal. We have no way of fighting or doing anything about extinction. You heard it here, okay? So when people say, well, what's the solution, Bill? There is no solution. And that's where we disagree with Guy. That's one of the issues. The other one is that, he believes it's got to do with climate change and maybe peak oil and some of the things that you hear about in the news today. He thinks that's going to cause some kind of catastrophe. And I'm saying we won't even make it to the 21st century, to the 2100s, right? To the end of the century. There's no way. We're going to go way before then, in my opinion, because, right now we are headed towards zero population growth sometime around mid-century if things continue as they are now. I think it's going to happen before then. But if we continue as we are now, we're going to hit zero population growth mid-century or thereabouts. And that means the economy, by then, it's not going to grow. Okay, because ultimately, the economy, the world economy grows because there's demand, and demand is population. No population, no growth, no demand, et cetera, et cetera. And so at that point, you hit a brick wall. You have this bottleneck. A lot of companies expect more sales next year. They won't get them. They fire people. Because they fire people, they have less purchases, less demand, and it's just a cycle. And I think that happened very fast. Just like if you look at the 19th century, we grew exponentially. In the same way, we go down exponentially. Okay, so yeah, that's the way I look at things. And I don't think there's anything that anyone can do anything about that. No politician, no economist can do anything about that. Okay, fellow says, you have to kill the bank industry. Again, conspiracy, right? The financial industry, that's it. Once done, a new era will raise. People actually believe that there's going to be a reset of some kind, and that once that reset is done, finally we're going to live in a paradise. Things are going to be okay. If we could just get those bankers off our back. It says, Bill, proposal is to be extinct. Exactly. And however, I like to be with hope. Well, maybe you have a false sense of security. Maybe you have too much hope and there is no hope. Maybe you're just fooling yourself. I mean, if you want to feel good, and you say, well, I'm not going to listen to you anymore, Bill. I'm going to go to this other channel that gives me hope. Yeah, fine. Go there and listen to beautiful music in your eyes. They say you're going to live forever, and we're going to get to this era where we have the technological singularity, and we're all going to have the robots fix our bodies so that maybe we live forever, and we won't have the bankers on top of it. We won't have to work. We'll have the robots doing everything for us. Yeah, you can hear all this beautiful stuff from Hollywood. And then you come here, and here we say, put your feet back on the ground, and we're going to tell you what's going to happen. What's going to happen is very soon there's going to be a collapse of the global economy. When, not if, but when that happens, food will be no more because no one will have an incentive to produce or distribute food to the cities. You got billions of people die in a matter of weeks. So, yeah, it's not a question of hope. It's not that I'm pessimistic. It's a question that I try to be as realistic as possible. If you do not subscribe to that theory, you have a different theory, well, I'd like to hear it, of course. Again, don't tell me your opinion, tell me your theory. Okay, here we have another fellow says, what happens when we die? I'm assuming he's referring to extinction, to humans, not individually. When we die, that's it. But when humans die, when we become extinct, well, we're out of the way, and we were a big influence on this planet. You could say we modified it or destroyed it quite uniformly all around. We created our world. And when we die, there's a couple videos out there that show what happens when humans are no longer here. And you see the grass is growing over time, right? Grass is growing underneath the cement and the highways and so on, and it becomes, a little different than what you see today. So if you were to come in a million years, well, you would see a different planet. And one of the things that could very likely happen is a runaway greenhouse. Maybe the Earth turns into something like Venus, and Mother Nature finally got all her, all the bugs off her skin, and she becomes a normal planet like all the others out there, just a rock with a barren surface like the moon. I think that's what's going to happen in the long run. We're not important, and will anyone ever find us? Absolutely not. We'll be crushed at some point. Maybe the sun expands in a million years, or sorry, in a few million years. More likely like in a billion years. And I think the number is 100 million. And within that time, no one's going to come and visit the solar system. And again, I'm saying that no one can travel, no life can travel interstellarly. It's forbidden by Father Universe, okay? No one can travel interstellarly. It's irrational to think of that, okay? But that's the baloney they sell you. I mean, I don't mind if it's science fiction. I love to watch it just like anyone else. The problem is when you believe it, and you believe then that the Martians came here, the Klingons came here, or the ETs are about to arrive, or we can communicate with them. That's the fantasy. No, we cannot travel interstellarly. It's forbidden by Father Universe, and I've talked about that in the past. But the point here is that, because of that, no one's going to come here. This notion of panspermia that people have, that a bug crawled on a rock and the meteor, came all the way to our side of the universe, our neighborhood, and populated the earth from that bug. Absolute nonsense. Absolute nonsense. No such thing as panspermia in Father Universe's universe world. Okay, we had Miss Universe contest, and here you see the evolution. We had the 11th century Miss Universe, and it was run by the Arabs, I think. Okay, that's where it started. Then we went to about the 16th century. That changed. All the women, they showed their stuff, but they had to show that they had some skills, and so they had to bake bread and who knows what in those days, maybe work the furnaces. 20th century, they came up with the bikinis, and you can see there the girls showing their bodies in bikinis. And now we have the 21st century version, and they're removing the bikini segment. No more bikinis. So my opinion is, that the golden age was the 20th century. Now, I'm not an expert, but that's what I vouch for, you know. But there's been a change now. There's been a change in the this year's, or not only this year's, but in the last few years. And now we have, for example, in this Miss Universe contest, we had the representative from Nevada, and it's this person, mispronoun. I mean, I meant to say mispronounced. They mispronounced his name because his name was Tommy, and they mispronounced it as Sally. And yeah, right now we have these X and Y's competing against the double X's, which is kind of weird. You know, I'm saying, hey, you know, I've been to Nevada, I've been to the casinos uh, several times, and I've seen some beautiful women out there in Nevada, and especially, you know, in that ambient, you know, casinos and so on. And I'm saying, this guy is the most beautiful guy in all of Nevada. This is the best they could find. And yeah, we have all these crossovers, you know, competitions. Here we have another one. This fellow, again, mispronounced. He's his name is Johnny, and I think they call him Betty or something like that. And he works for Victoria's Secret. This is what they want to show you. Okay, and so the question is whether this is something normal. Okay, with is this the future? Okay, for the new generations. Here you see them again, all these folks, and you have also the crossover in. I showed this a couple weeks ago, where you have the fellas who are changing their sex and doing some kickboxing and all that good stuff. You know, they're fighting against women. And so the question is this normal? Does this have a future? Is this the future of the world that we're seeing here? Or do we want to go back to civilizations to the 20th century? So food for thought, you know, I mean, and again, one of the comments made for the Miss Universe contest was that, you know, it's changed quite a bit and a lot of people have lost interest. And I don't blame them. I mean, if they're gonna remove the bikini segment, you know, they're removing the bikini segment from there. They want the girls dressed because they're competing for college careers or who knows what. And here you have the other ones in Ocean City, and they want to show their breasts topless, you know. So the world's upside down today, you know. So the question is, does that have a future, or are we moving in a certain direction that also is a sign that something is wrong, and that maybe, you know, just maybe it's part of that extinction process where some things are going to be weird. Food for thought. Okay, so let's get on with the segment on physics. And what are we going to do today? We're going to talk a little bit about electricity. But we had a couple questions, a couple things that remained apparently unresolved for some people. And so let's get to those first, okay? Let's look at this. One fellow says, get him up here, says, Chris Langdon, he talked about that the other day, or I mentioned him, basically said the universe is God, and we're equivalent to its brain cells. Okay, I don't know why he says it's, should say his, but yeah, we're in the age of pronouns. A lot of the CTMU, okay, is restating, meaning the theory that this Langdon fellow proposed, is restating old esoteric beliefs using math and predicate logic. It's not physics, it's metaphysics. It is worth reading, in my opinion. Well, I don't think so. And let me tell you why. And I'll go here with the only good thing that Mr. Rutherford said, and that was a long time ago, okay? Beginning of the century, he said, all science is either physics or stamp collecting. You know, you have all these so-called philosophers, Plato and Kant and Ayn Rand and so on, and all these people called themselves or thought of themselves as philosophers. And no, there's no such thing as you know, none of these things like ontology and metaphysics and epistemology and philosophy of physics. No such monsters. There's either physics or there's stamp collecting. Okay, so That's one thing that Mr. Rutherford said correctly. Okay? And so, this nonsense about metaphysics, what the hell is metaphysics? You either do physics or you do stamp collecting, period. Okay? Straightforward. Okay, and here we do physics. So if you're going to move concepts around, well, you're doing stamp collecting because you haven't provided a physical interpretation and explanation for a mechanism. Okay, another fellow says another issue needs to be resolved, and this issue, mass versus weight. Some people are still stuck on this, and they're going to fight it to the last breath because this is what they learned in high school or college or whatever. And no, we need to settle this and kill the notions because it's irrational. Okay, and we'll see it here. Fellow says weight is a dynamic concept. It takes two frames of reference to measure. Your scale at 0 and your scale with weight. And again, no, weight is not dynamic. Weight is static. And let me show you here. Let me give you a picture of why it's a static concept. Okay? And here it is. It's a static concept. Why? Because science doesn't do measurement. Okay? That's the religion of mathematics. Okay? In science, we have to explain. We have to give a rational explanation to a mechanism, to a physical interpretation. That's what science and physics are about. Okay? You either do physics or stamp collecting, again. And it's in mathematics. The mathematical physicists, those are the people who talk about measurement and about equations and about describing. We talk about explaining. That's the difference. Okay? And weight is location specific. You have a different weight for different locations in the universe. Even before you measure, you have weight even when you're falling, from the sky. You say, well, I don't feel my weight. Yeah, you don't feel your weight, but hopefully you did not acquire weight all of a sudden when you hit the scale. And then it turns out that the mathematicians, not me, but them, they're telling you that once it hits the scale, that's called mass. Because that weight, that pull of gravity of the ball in this case, against the scale, now it's static, it's staying there, it doesn't go any further, and the needle moved, right? Now you have what they call mass. It's a measure of the amount of matter that you are measuring. And one fellow says out there, well, we can convert it, by using the mole equation. We can convert those into atoms. We know approximately how many atoms there are in there. Fine. If that's what mass is, specify your answer in quantity of atoms. Tell me there's 1,000,000,001 atoms. That would be the way to specify mass. But to say it's 1 kilogram, that's a measurement. I thought that was weight. And again, we don't have to put the weight or throw it on something. You already weigh, you already have also a certain mass, number of atoms, before we measure anything, before we put you on the scale. The scale is only to find out exactly how many either atoms or how much you weigh. Okay, that's what the scale is for. Before you put anything on the scale, you already have both weight and you have mass. You have a certain number of atoms in your body. That's called mass. Okay, number of atoms, and you have a certain weight, which is how much the Earth or the Moon or the Sun is pulling on you, on the astronaut. Okay, so you already have a certain weight, a certain mass before you do anything, before you get a number. And people don't understand that. They think that you got to run an experiment, weigh something on a scale, put it on a scale, and then you only have weight. But that you don't have weight until you do that. Not true. Okay, so try to please get that through your head. Okay, and again, I don't know why people have difficulty understanding that. Maybe their religion is being sacrificed, and they don't like that. That's what they learned by rote. And so when someone tells them, look, you just memorized stuff for the test on Friday and you got the test right, but you never learned anything because you never learned what was secretly happening in that invisible world of yours, You know, and now you say, well, no, you already had weight, you already had mass before you put it on the scale. And say, whoa, I thought you needed to measure, I thought you needed to weigh something. You don't. You have weight before you weigh it. You have mass before you mass it. Okay, so let's get on with electricity now. Here we go. And we start out by defining. We have to find out what a definition of electricity is out there. And the first rule is that if you can define it, that word is not an object, does not represent an object. Objects we do not define. Objects we point to, name, we draw, we present them, we show them, you know. Object is that which has shape, not that which you can see or touch. Okay, and so if electricity is defined, electricity is not an object. I had people from the electric universe who told me, "What do you mean electricity is not an object? Of course it's an object. It's a thing." Okay, why? Says, well, stick your fingers in an outlet and you'll find out why. That was their answer. Yeah, you get a shock. And so the question was that electricity or was it an atom? Was it an electron? You know, electricity is a concept, dynamic concept to be more precise. Whereas what touched you must have been an atom or a part of an atom. And so an atom is not electricity. Electricity is not an atom. Electricity is a process. Okay? And all dynamic processes are concepts. So how do they define it? They say electricity, motion of matter that has a property of electric charge. Okay, I love the fact that they use the word electric to define electricity. Okay, that's great. But let's find out what this chargy thing is. It says chargy, it's the physical property of matter that causes it to experience a force when placed in what? In an electric field. So we have the electric there, electromagnetic, right? Electric field. And so electricity is a charge and charge is electric. Great. Sounds like a circular definition, you know? Go around in circles here. So what is a field? Well, a field is a bunch of numbers. That's what it is. Value at each point in space. So we have a bunch of numbers, and what they're saying is what that you experience, if you're put in an electric field or electromagnetic field, right, you experience a force, well, we call that a charge. And so you have this lady here, we put her in a field, bunch of numbers floating around, I guess, and she experiences a force. And they say that was charge. Okay, but what is it that touched you? Was it this chargy thingy? What is it, a ghost, a spirit? I mean, we need to get to the bottom of this charge thing, apparently, because that's what's going to define electricity. We need to figure out what electricity is. They say it's something related to charge. Charge is some kind of spirit that causes a force on you when you're in a field of some kind. Not a poppy field, not a marijuana field. No, it's got to be an electric field, okay, or electromagnetic. Okay, let's find out. Turns out that this chargy thing also moves, okay, even though it's defined. So we have a concept here that's going to be moving around. It says charge originates from the electron and proton. Okay, that's in the atom. Great. So now we know where it comes from. By convention, the charge carried. Okay, so we're going to carry this charge. You know, remember, you can carry watermelons, you can carry chairs, maybe even rocks, and they're going to carry a charge. Okay, carried by electrons is deemed negative, and that by a proton's positive. Okay, so we have these negative and positive charges that are carried by electrons. Okay. And protons, right? Okay, let's find out where they're getting to this. Each electron carries the same charge of approximately minus 1.6 times 10 to the minus 19 coulombs. Okay, sounds like a number. So this charge thing apparently is some kind of number. And so how do you carry a number? You know, so now it's getting weird because they define charge as what? A force that you experience in an electric field. Now they're going to say it's positive and negative. It comes from the atom, apparently. And then you have the electron and the proton. They carry these 1.6 times 10 to the minus 19 units, known as coulombs. So I'm not sure what they're talking about. I think they're confusing numbers with physical entities here. It says the movement of electric charge, you're going to move this number, is known as an electric current. So now we know what an electric current is, which is this electricity thingy, and it's the movement of this charge, which is a number. So we're going to be moving this 1.6 coulombs concept, right? And that movement of that coulomb is what they call electric current or electricity. I hope you're following through, okay? Current can consist of any moving charged particles. Now they're talking about moving particles. Okay, so are we moving particles or are we moving numbers? What is it that we're moving? Well, the way they do that, they have this device that measures, right? Remember measuring? And what does it measure? It measures numbers. It measures units, measures quantities. So they're not measuring particle. They're not really measuring a thing. What they're concerned about is the number they get out of that device. And they say, oh, so many particles, each particle has so many coulombs. We're not interested in the particles. We're not interested in what's going on in there because we don't even know if they are particles. What we're interested in is how many coulombs have gone by. That's what they're looking at, okay? And it says charge in motion, again, constitutes a current. Okay, electric current will not flow through an electrical insulator. They don't explain to you why it doesn't flow. They just say it won't flow, but then we're talking about electric current flowing. What was electric current? What was the movement of a charge, which is a number? So we have the flow of a movement. Oh, that's great. I mean, I think we're learning quite a bit here. The flow of a movement. And what's the movement of? The movement of a number. Coulombs. Okay, I hope you learned a lot, okay, from all this, these definitions that these people have, okay. Let's see if we can find out what they're looking at, okay. Well, what is this movement of charges? Okay, so here you have, it says when a charge is placed in a location, okay, with a non-zero electric field, a force will act on it. Okay, so we have this force. What is a force? Concept? Because we're not talking about a rock, we're talking about a force. And force is what? Pull or push, I guess. So I guess there's pull or push is going to push or pull. Okay, so the push and pull is going to be affecting this, this charge, okay? If the charge moves, okay, this number, this 1.6 coulomb, 10 to the minus 19 coulombs, if the charge moves, the electric field would be doing work. We talked about work the other day, okay? On the electric charge. The presence of a charge gives rise to an electrostatic force. Charges exert a force on each other. So we have here a mixture because they say charge is essentially this 1.6 times 10 to the minus 19 coulombs. Okay, that's what charge is, because they're talking about the charge on the electron. They say the electron carries the charge, you know, like the watermelon or the rock that you carry on your shoulder. So you're carrying this charge, whatever that means, physically, from a physical standpoint. And this causes a force, causes work, if it's moving in an electric field. Okay, let's see if we can go a little deeper on this, see if we can get to the bottom of this. Here we have the field, what is it? You look it up, it says a value for each point in space and time. Okay, so let's illustrate this. We're just going to go by what they say, okay? We're just going to go literally take them at face value. They say a value for each point in space and time. Let's do it, okay? We can do this. I'm sure we can. Here it is, okay? There's your field. Value at each point in space and time, okay? So we have the field, okay? Now what do we got to do next? Well, we got to put a charge in there. And for that, you need to know what a charge is. Okay, so what is a charge? Okay, let's put it in there. There it is. Charge is 1.6 times 10 to the minus 19 coulombs. And what are they going to do? Well, it says the charge moves inside the field. And that's going to cause work and force and all this other good stuff. One charge affects another. Okay, and it looks more or less like this. Okay, now that we have it there, there's your charge moving. Okay. We have numbers moving inside numbers. That's all we have so far, according to their definitions. According to, you know, we're following them to the letter. And you might say, Bill, you're making fun of these guys. All these people did so much work for the last 100 years, 150 years maybe. on trying to figure all this out, and you're just making fun of them. Well, no, I'm applying what they're saying. I'm using their words, their own words. I'm not raising any, straw man here. I'm using their own words. I'm saying, what are you talking about? I'm talking about a number. What's a charge? It's a coulomb of some kind. 1.6, blah, 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 blah. That's a number. Okay, what is a field? A bunch of numbers. So we have a number floating in a bunch of numbers. Maybe they're moving, maybe they're not moving, but the point is, we have numbers inside of numbers. What does this have to do with physics? What have we learned about what's going on in that invisible world? A number moving inside a bunch of numbers, field of numbers, value of each point in space. So this is what we have. I'm just going strictly by what these people are saying. Okay, I'm not putting words in their mouth. I'm not making fun of them, even though that's how it comes across. Okay. So let's find out if we can get a little deeper in all this electricity stuff. It says a lightweight ball suspended from a string can be charged. Okay, we're going to charge it because we're going to put all these coulombs in there, right? By touching it with a glass rod that has itself been charged by rubbing with a cloth. Okay, good. If a similar ball is charged by the same glass rod, it is found to repel the first. Why? Because they both have the same charge. Either they are both so-called negative or they are both positive. We still don't understand what negative and positive are. These seem to be just descriptions, maybe qualitative descriptions, because we have no idea what that means physically. Okay, and so if they have the same charge, they push each other apart. Two balls that are charged with a rubbed amber rod also repel each other. Okay. However, if one ball is charged by the glass rod and the other by an amber rod, the two balls are found to attract each other. And again, all we have is just a description. And you say, Bill, why did you put the magic wand? Well, that's the rod that I used. But the point here is that so far we have magic because they have not explained how this is done. All they said is, it is so. We saw it in the lab. Well, yeah, you saw it in the lab, but I mean, what are we talking about here? Why does this happen? What is causing the positive to attract the to repel the positive, negative, and for the positive to attract the negative and vice versa? What is happening there? Why are they doing that? What is this negative? What is this positive? What's happening in that invisible world? And all they do is they have a description and say it does so at this speed or at this acceleration. This is the force and this is how much work it created. And those are just numbers. Those are units, numbers followed by units. What have we learned about what's going on inside there? What have we learned about physics? And again, Mr. Rutherford says you either do physics or you do stamp collecting. This is stamp collecting. This is just measuring and saying this is what I saw in the lab. Well, you don't need to use brains for that. I mean, you just have to say, okay, I went to the lab. What did you see? Well, here, I saw a ball and I let go of it and it fell downwards. So you describe it and say it went so fast downwards. It went such a distance in so much time. That's science? That you describe why the ball or how the ball fell to the floor? Why don't you explain why the ball didn't go up to the ceiling? That's what we would like to understand. Why did it go downwards? What caused it to go downwards? That's where you have to use your brains. But to say that you observed and you measured that the ball fell downwards every time, and you can do it also at home, you can repeatable experiment. Yeah, so what have we learned about physics? All we did is have a mathematical description so far. Okay, so this is what we're getting with this electricity thingy here. Okay, and so says, we've got to look at this positive, negative. Okay, and so we need to find out what we mean by this, right? A positive current is defined as what? Having the same direction of flow from the most positive part of the circuit to the most negative part. Like if we understood something there, a positive current is what? From the positive to the end, to the negative. Great. Current defined in this manner is called conventional current, okay? But the motion of negatively charged electrons around an electric circuit is deemed positive in the opposite direction to that of the electrons. However, depending on the conditions, an electric current can consist of a flow of charged particles. Okay, we're gonna now it's not flow of charges, but charged particles. What are those particles? They are coulombs. That's what those particles are. In either direction, or even in both directions at once. So have we learned anything? So it means the charges can move in one direction. They can move in both directions, and they call it, if it goes in this direction, we call it positive. If it goes in that direction, we call it negative. Those are all descriptions. So far, we have not learned why, what causes something to go in the negative direction or in the positive direction. We have no idea why one charge also opposes a similar charge and attracts a dissimilar charge. Why a negative attracts a positive, and why they flow. And then when you get down to it, they say, well, what was this charge that you talked about for the last 2 hours? Oh, it's a number. 1.6 times 10 to the minus 19 coulombs. That's what it was. Okay, so this takes us to alternate current. You know, there's a difference here. Remember, you got direct current, which is the flow of electron beads, I guess, from atom to atom, from one pole to another, from the positive to the negative, or maybe it's the other way around, who knows anymore. But then you have the alternate current, and that's a big problem because you're saying, hold it, if you turn on the circuit, you have a closed circuit, and now all the electrons flow in one direction, right? And that causes some effect because you can put a light bulb there and it turns it on, great. But now you're going to run it in one direction, then run it in the opposite direction immediately. So it goes back and forth at great speeds. Are the electrons going all around to the other side and then coming all the way back to the other side? Is that what's happening? They're going around in complete circle in one way very fast and then in the other direction very fast? And they say, no, not quite. Only when direct current do the electrons move in one direction. But when you have alternate current, it goes back and forth. And here it is. Direct current is unidirectional flow from the positive part of a circuit to the negative. Okay, great. This flow is carried by electrons. I like the fact that they carry the flows. Okay, yeah, they carry motion all the time. I like the way they talk. Alternating current pulses back and forth within a conductor without the charge moving any net distance over time. So now for alternating current, there is very little motion. It just goes like back and forth or up and down. There's no real motion going to one end and the other. So how do they produce effects if no electron is reaching, the opposite pole? Like if an electron is negative, so-called negative, and it has to reach the positive pole, great. I mean, if it just moves back and forth locally, it's not reaching the end of the line. It's not going to the end of the station. So how do we imagine this in the real world of physics? It says it delivers energy. Aha! Now we introduce the word energy. First in one direction and then in reverse, okay? While the particles themselves can move quite slowly, sometimes with an average drift velocity only fractions of a millimeter per second, the electric field that drives them itself propagates at close to the speed of light, enabling electrical signals to pass rapidly along the wires. So what they're saying here is the electrons, they're not going all the way. They're just moving back and forth locally. We don't know why. We don't know what, are they changing atoms? Are they moving from one atom to the other? Or what's going on here? Okay? And they say, well, that's moving very slowly. They drift very slowly. They usually use this explanation for alternating current, okay? And what they say is that what really travels is the field, okay, and the signals. So what's really moving are the field and the signals. And here you get an idea, okay. You have this situation. Here's the direct current, okay. Let me get this out of here. And here you have the direct current. It goes in one direction. They go all the way, and this is what they'll show you for direct current. Okay, no problem. I think we can deal with it. But what happens when you look at alternating current? And here you see it, side by side. So now, is that a little weird? In one case, the electrons go all the way, and we can understand all the electrons going through there. But in the other, the electrons just go back and forth, or maybe it's up and down. Maybe they just vibrate up and down. The question is, are the electrons going from one atom to the next? That's the question. And if they are they coming back to the first atom? So an electron leaves one atom, goes to the neighboring atom. Now it's coming back and coming to the first atom back again, or maybe to another one, another neighbor nearby. But it's going back and forth. And the question is, what is triggering this electron bead to move, from in this conduction band? In other words, going from one atom to the next and back again. What's the mechanism? To say it is so is just their interpretation. It doesn't mean that they've figured out how the universe works, how Mother Nature does this magic trick. Okay, so unless they can illustrate it, they've said nothing. Nothing in physics. They did stamp collecting. That's what they did. Okay, here we have a fellow we talked about the other day. His name's Derek Miller, and he says that the electrons really don't flow like all around. What they do is they move very slowly, just a millimeter or micrometer, or who knows how little they move. And again, you would think that they're moving from atom to atom, and they don't talk about that very well, what's happening there, because they say, yeah, the electrons move. Well, what's happening? I mean, are you saying that an electron is moving from atom to atom to atom to atom to atom all the way to the end of the station, the end of the circuit? And then when you have alternating current, it just moves from one atom to the second atom, then back to the first atom again. How does that make the light turn on? I mean, and how is that problem? What's triggering, what's pushing the electron out of the atom and forcing it to be at the neighboring atom and back again? What force? What is this force? What is it, a spirit, or what is it? Okay, and here we have Mr. Derek Miller, and he said, well, electrons don't really go around. Okay, they do, but they don't. And he's got really a confusing image of all this, dynamic image, where he shows the electrons moving in one direction, remember, from atom to atom, right? But the current is flowing in the opposite direction. See, you see it here, okay? You have the electrons, which are those green balls, they're moving towards the left, but he says the current is towards the right. Great. I mean, very, very straightforward, okay? We don't know what he's talking about. What's moving to the right if all the electrons are moving to the left? Okay, but so that's how he illustrates it. But then he says this notion is wrong anyways. Okay, and what it truly is something like this. Okay, he didn't illustrate it. I had to illustrate it for him, what he said. And he's saying it's more or less something like this. Okay, where the electrons are really like moving very little, maybe moving to the side, maybe back again, especially in alternating current, or maybe they're just moving up and down, from atom to atom, or who knows, because they don't specify what is happening physically. They just say, we measure the coulombs, we measure the electric current, the AC, the DC, the current, the amps, they're talking about measurement. They're not talking about what's physically occurring in that region of the wire, okay, along a wire. And okay, let me move this out of here. Give me a second here. Okay, so what's the problem with this? Well, among others, this is the big problem. The problem is they don't have an atom. We don't know what their atom looks like, okay? And here it is. This is their atom. Make it a little bigger here. What they're saying is the electrons are moving from atom to atom. But this model requires the planetary model, the Bohr-Rutherford planetary model of the atom. It's saying that, you have this little bead that's going around or is in different energy levels within certain orbitals, as they're known. Okay, great. So what keeps that electron from flying away completely? Why does it stay there, and what causes it to move from atom to atom later on? So we don't have causes, we don't have mechanisms. All we have is an assumption that the electron is a little bead, little particle that is in an orbital or energy level. which is a region around an atom, we know for no reason why it's doing that. We don't know why that electron doesn't fall to the nucleus. We don't know why that electron doesn't fly spontaneously away. And then when you have electricity, like you see up there, direct current, okay, it goes from atom to atom for no reason whatsoever, simply because it likes it. Say it's a voltage. Well, what's a voltage? Well, think of it as a river flowing, like, downhill from the mountain to the valley. That's an analogy. Give me what's happening inside that world. They cannot imagine. They cannot make sense of it. Okay? That's the problem. So electricity is first defined, which is a problem because people want to treat it as a physical object. And if you define it, it's not an object. An object is that which you can, which has shape, which you can point to and draw and illustrate and see. Okay, but you can see it only because it has shape. Even if you're not around, it has shape, irrespective of you, and you don't have to touch it either. An object is that which has shape. Does electricity have shape? And no, because it's a process. It's like fire. Fire is combustion. There is no thing called fire. But people say, "But I can point to it. I see something. I see a shape." Yeah, it's a process. It's known as combustion. The object is oxygen molecule or atom. Okay, so we have to learn the wording in physics. Okay, so what do we have here? Here we have the electric universe, and they fight against the establishment, but they do the same thing as quantum mechanics. I mean, their name is Electric Universe, and here you look them up under the Thunderbolts Project, which is their site, right? Their primary site. And you say, what is electricity? Okay, and they say electricity is a fundamental quality of matter. So it is used to characterize other things, thus consensus opinion is lacking precision. In other words, they're already giving you the fine print. They're saying they're not going to be able to define it. Like all bedrock presumptions such as gravity or time, reducing electric terminology into smaller units is impossible because it lies at the bottom of the lexical well. And you can see the troubles these people have in defining the word electricity, even though it forms part of the title of their organization, the Electric Universe. Electricity, how do they define it? They define it as the flow. It's a flow of something, okay? Electricity is a flow. Therefore, electricity is not a physical object because it is a flow. Give me a second here. And so what is it? Flow of what? Electric charge. It says this flow travels. Okay, it travels through a circuit. Okay, and then you see next to it there it says electricity moves through a DC circuit in the wires as particles of charge. So we have electricity is defined as a flow. Now they're going to say that electricity, this flow, it moves. Okay, so the flow is moving. Okay. And so we run into all these troubles, okay? Because they have all this wording that simply takes them in all these directions that they cannot explain, they cannot justify, they cannot illustrate for you. They define electricity as the flow, and then they say the flow is moving. And then they say that electricity is a physical object. Okay, so you figure it out. Okay, so here we have their version. They say, what is electricity? It's the flow of electron beads from atom to atom. Here you have a circuit, anode and cathode, and this is essentially what they have in mind. What do we propose instead? Well, we propose something that looks like this, okay, compared to theirs. Okay, let me get this one out of there. And what you see is the comparison. We're saying that all these shells, electron shells, are merged and they spin in situ. So they're twirling around. So our version of electricity is a little different than theirs. And again, yes, electricity is a process, a dynamic process. Okay, so let's get to the conclusions. Okay, what have we learned about electricity from all these people? Well, here it is. Math Viz. Electricity is the flow of charges. That's what they say. What is a charge? Well, it's a number. What is a field? It's a number, a bunch of numbers. So we have a charge number floating inside a field, which is a bunch of numbers. Okay, that's what you have today, because that's how those words are defined. It's not that I'm raising a straw man or putting words in their mouth. This is how these words are defined. If you don't like them, define them in a different way. If you think they are physical objects, illustrate them. That's how simple it is. And if charge is a number and field is a bunch of numbers, well, you have a number and a bunch of numbers. That's what force is, or power, or the work that charge does inside a field. What have we learned? And so charge, moving in a field, that's what a force is, okay? It performs work. We talked about that the other day. There's no definition for positive or negative. Okay? We don't have any notion of what that means in physics. They just say positive, arbitrarily, we're going to call this one here positive, this one here negative. That's it, whatever that means. What does that mean in physical terms? We have no idea. And why does positive attract negative? Again, we have no idea. We have a mathematical description, no physical explanation. AC circuits don't flow. They drift locally. They just go back and forth. See, when you see that going around, that's a direct current. And they say, see, this is electricity, all these beads going around from atom to atom. But then for AC, they have them going back and forth between the atoms. And you say, well, so this electron never reached the terminal. You see what I'm saying? It just goes back and forth. In fact, it drifts slowly, they say, in both directions, I guess. So AC is a little different than DC in the notion that they have in the physical interpretation of what's happening to the electron. That's my point, okay? Fields and signals are the ones that flow, and they flow at the speed of light. Okay? So what they say, no, the electron is not what's flowing. What's flowing is the field. What is a field? A bunch of numbers. What is a signal? A concept. Information. They say information flows, energy flows. Those are all concepts. So we haven't learned anything. We don't know what physical entity is flowing. You can say that a river flows. Why? Because there are atoms. So the atom is floating and flowing. We can understand that. But when you have a number that's flowing, well, that's a little difficult to illustrate. Okay? And then, they use the planetary model of the atom. That's another no-no. Rope model, very simple. It's merged shells twirling in situ, and it looks more or less like this. Okay, that's our model. It's all physical. It's all done with objects. Okay, we have the atoms are merged, the electron shells, okay, or membranes, they're merged, and they swing the threads around themselves, which are going to form the magnetic field. Field is not a bunch of numbers, at least a magnetic field is not. It's a bunch of threads, physical threads that are twirling around the atoms, aligned atoms, because that's what electricity is. Okay, let's get on with the questions and comments that people made this week. And here we have first one. Let me get myself set up here. Get rid of this one. Okay, went all the way to the other side. Fellow says, why the quantum wave function collapses. Okay, he's trying to answer that. He says, the wave function completely explains and simplifies quantum mechanics down to such simplicity a grade school student can understand it. Maybe people understand it when they think they understand it, but they're not understanding physics. What they're understanding is mathematics. The explanation is what's irrational. You can't say a wave function has anything to do with physics. There's no such physical entity known as a wave function, especially if a wave function collapses, okay? And the other fellow says the wave function is a mathematical tool. It doesn't really describe a single particle, but a whole set of identically prepared particles. So it's a bunch of particles, okay? Great. And I put particle in quotation for two reasons. Oh, let's see why. Let's see why. The first reason is that something is only a particle when it is has a detectable interaction with something on a precise location. Touch, see touch? Yeah, they think that a thing is that which you can touch because that's what they do in the lab and that's what they measure. None of that has anything to do with particle, with why and what the definition of the word object. Object is that which has shape, not that which you can touch. But see, they say the particle becomes a particle when you touch it. Until then, what is it? Well, it's a wave function. What is a wave function? A number. And so these people are all irrational, and this person says it's so simple, even a high school student can understand it. Yeah, the problem is that you didn't understand what you understood. That's the problem. Okay, and secondly, because also combination of particles can have a wave function. In other words, he's talking about many waves. The ether that's waving around, you know, in the ether in space, because space is made out of ether, so we don't know what it's moving in. Nothing. There is no such thing as nothing in mathematical physics, so we don't know what they said from a physical point of view. Physics, we have no idea what these people are talking about. And another fellow says the wave function, really the excitation of the boson and or fermion field. So we have the excitation of a field. What was a field? A bunch of numbers. So we're going to shake all these numbers and excite them, and that's going to be the wave function. Okay, so what is a field? Bunch of numbers that are shaking. Okay, so keep that in mind. There is no physical entity called field because it's defined by the mathematicians as a bunch of numbers. You don't like the definition? Change the definition. If you think a field is an object, point to it. Make a drawing, illustrate it. Then we'll know what you're talking about. Otherwise, if you're going to define it and you're going to define it as a bunch of numbers, and then you tell me that you're going to excite these numbers, well, we have a problem with that because you're an irrational individual. Okay, it stops being fuzzy or spread out when it finally interacts with another wave function. So we have wave functions interacting with wave functions, and they call that the quantum field theory. Great, we learned a lot. So we have all these concepts, these numbers that are interacting with each other. That's all we see in front of us. And you might say, well, Bill, you're taking this too literally. Well, okay, make it literal, or make it unliteral, whatever you need to do. But we need to know what's happening there. Illustrate it. Okay, don't talk, just illustrate. And the interaction can happen at a collapse. Again, you can go on with what words do they use? Both energy, bosons and matter, fermions. They have all these concepts, and they're playing around with concepts, and they think they're being rational. And the worst part, they put this out there like, yeah, we've proven this. This is a done deal. You just got to memorize it from now on because it's already been proven. And you wonder about their mental state, if they even realize what's coming out of their mouths. And talking about that, one guy says I misrepresented him. Beat me up. He says, do you crop and misrepresent my comments on purpose, or do you have a reading deficiency? Okay, I'm so sorry. What did I do here? Okay, one more time, since you take any opportunity available to mischaracterize my arguments. Okay, I'm so sorry. I shouldn't have done all that. Okay, I use object and shape as synonyms. Yeah, they're not synonyms. That's why I have to clarify. That's why I have to beat you up, Let me get my dough roller. I'm going to do some justice here, okay? What he says, it's what has one boundary. So he defines object or shape, right, as that which has one boundary. And he says anything unbounded is not an object, isn't a shape. Okay? Yeah? Okay, and then he goes on, he says the following, or this is how this is when I have to use my dough roller. That which has single boundary, that's what shape is. Okay, what is boundary? Well, he says it's left undefined. Well, why did he leave it undefined? I think he should define every word in the dictionary. I mean, if we're going to define, let's be serious about it. Let's define every single word in the dictionary, or we won't understand what shape is because we don't know what boundary is. We don't know what an object is. Let's define every word in the dictionary. Okay, that's what we should do. But he says boundaries left undefined, but can be put into everyday speech as where the shape ends. Well, why couldn't we leave the word shape
in everyday speech as, whatever it is. Why did we have to define the word shape? And again, I say that only idiots attempt to define the word shape. What is an idiot? An individual with big ideas. In fact, you can see it here. The guy defines shape as a single boundary, and then he defines boundary as where shape ends. Well, sounds a little circular, doesn't it? I mean, these are the bright guys that think that they're going to be able to define words. And the reason they do that, all of this is because the definition of the word object destroys their religion. Okay? So, no, shape and object are not synonyms. One refers to the thing, and the other one is a qualifier of the thing. One is an adjective. Shape is an adjective for the purposes of physics, not a noun. On the other hand, object refers to the thing in front of you, and so the object is what you pointed to, what you drew, what you illustrated, the thing that has shape there, whereas the shape is a property of that thing. So one is a qualifier, one is an adjective, one describes what the object has in common with all other objects. They're not synonyms. And how do you explain that to them? These people see their religion die before their very eyes because you're saying, hey, the word object destroys your religion. They realize this, so they're going to fight it with everything they've got. They say, no, but I'm not going to let you kill my religion. You're not going to rape my virgin, What are you doing? Okay, so they continue a lot of things that are related to object again, Fellow says, two objects may completely superimpose without fusing. Okay, remember I said touch, the word touch is blending. You have to have two objects turn into one. That's the definition of touch. Okay, zero distance. Okay, zero distance, blending, etc. I don't know how else I can, in fact, I'll illustrate it in a minute. But he says, with this framework, I define touching as two objects whose boundaries overlap. Well, how did they overlap? How did they touch if there's space between them? Otherwise, you wouldn't have two objects. You still have space there, and as long as they have a boundary, they have space between them, because that the ultimate thing that encapsulates them is this non-thingy we call space. As long as there's space there, you're going to have a boundary. Only when there is no space whatsoever, when the boundaries disappear, that's when you have touch. Now you can talk about touch. What happened? They blended. They turned into one object, a single object. In this case, a figure eight. It would be with two balls there, right? Okay, now it's possible to do push-pull without objects permanently fusing or having a magical gap of no contact between. So they reach these irrational conclusions, that one there, because they misdefined the word touch, because they have an erroneous, irrational version of what touch is. They say they don't need to touch. My definition of touch is boundaries overlap. And now I can continue, right, with this irrational definition and say, see, now I know I can pull or push even though they're not touching. The guy is killing his own definition, okay? Will you answer how your threads push and pull without touching? My God, and I keep telling them the threads don't touch. So he says, how do they push without touching? Well, they don't push. They go through each other. That's the point. But let's go step by step here, okay? Here we have touching according to what he's saying, or what many people say. They think it's just surface against surface. But as long as you have two objects like you see there, they're not touching because you have space between them. And you say, well, is there space if they're touching? Well, if they maintain their surface, if the surface remains intact and doesn't blend with the other one, then they're not touching. It means ultimately there's space encapsulating them, and you take God's microscope and you go in there, or telescope, whatever, and you look in there and you'll see space. And you put them closer together and you expand that with another microscope and you see space. And there's space and space and space and space. The only time that space disappears is when the two objects blend and their surfaces, at least at one point, at least in the surface, becomes common to both. Then they became one object. Now they're touching. Touch one object. Touch, blending. Okay, please understand before one of us dies. Okay, so here we have, that's touching. Touching means that they blend, become one object. Figure 8 in this case, just an example. Okay. Okay, and what this fellow is proposing instead is something like this. Okay, he's saying they overlap. Are they touching? Well, as long as each object maintains its surface, it's surrounded completely by by space, you can say. By that nothingness we call space. Okay, so this is where the problem is. Okay, give me a second here. Remove all this stuff. Give me a second. Okay. Okay, so because of that, we reach that even in the real world, we have blending, not of the ropes, not of the threads, but of the unit of mass, which is the atom. The smallest unit of mass is the hydrogen atom. And here you have a situation where the two objects blend. Okay, why? Because one is drawn into the other. The threads are blended in that sense. They're not blended. What happens, the thread continues from one atom into the other. So in that sense, these two objects have become one. The hydrogen molecule is touch. That is touch. Why? Because they blended. Okay. Now, does that mean that the thread blended with another? No, it's the same thread that now, because they're so close together, goes into the other atom. Okay. So they screw into each other, but it's the same thread. Okay. So again, you have to find out which is the system. And the system here is the atom, not the thread, not the rope. Okay, let me repeat that. The system that we're analyzing are the systems are the two atoms. Okay, so the two atoms are blending, not the threads or the ropes. The atoms are blending. Okay, so let's find out which one is the object. We're talking about the two atoms touching, not about the ropes or the threads touching. Ropes go through ropes. They don't have the ability to touch another rope. Okay, and so the fellow asks, he continues, he says the following, and again, I hope these clarify questions for other people who have similar inquiries. We made it to the big question. Good, finally. Okay, how do you pull tangible objects with intangible objects? I guess he's suggesting or insinuating that you have the rope. Rope is intangible, okay? And he says, how do you pull with these things if they don't touch? Well, you have to remember that the rope, the two threads of the rope, right? They go into an atom, they form the atom. So it's not like they're connected to the atom, like something else that's connected, like, you put a hook there or something. No, what they are is they go into and they form part of the atom. And then on the other side, the rope comes out and goes to another atom and so on down the line. So it's a train of ropes followed by atoms, followed by ropes, followed by atoms, all one thread. So it's not like it's attached, hooked or whatever, where you say, oh, if this is intangible, how come it touches something which is tangible? No, the thread goes all around the universe. It's one thread. And so ropes convert into atoms, convert into ropes. It's a single system. Okay. And so what happens when one atom slides along the rope? Well, the atom doesn't touch the rope. The atom is going to touch another atom, like I showed just a minute ago, where it blends in with another atom. But meanwhile, what happens is it slides along the ropes. So here we have an example which I've put in the past, which is you have the atoms that form your fingers, okay? And just put one atom per finger. That's all you got there. And as the hand slides towards the ball, okay, the ropes that connect the atoms of the ball to the atoms that form your hand, your fingers, right? You're sliding your hand along those ropes.
okay? And you're not touching the rope. What you're doing is your atom is sliding through them like a bead on an abacus, and the ropes are going through because they're forming part of your atom, right? They're going around the electron shell and the proton dandelion, as we call them. And what you're doing is just sliding through the ropes. You're eating into the rope as you move. So you're not touching the rope. And again, you got to identify what the objects are. The objects here are the atoms, not the ropes. So you can't touch the ropes. But at the same time, are you pushing or pulling on that ball? Well, no, what you're doing is sliding through the ropes. Okay, that's what the atoms of your body are doing. Okay, here we have another question related again to all these. Let me remove this for a second here. Give me a second. Related to the word object, which destroys their religion. As you can see there at the bottom, the definition of the word object destroys all religions. Absolutely. And that's what these people fear and hate. And, oh, how can you do this to us? So he said, you said everything you can draw or imagine has shape. No. I said that everything that is an object has shape. And if it has shape, you should not have a problem drawing it. Okay, let's get it right. Let's get the wording right. Let's understand it correctly. Okay, so he says that anything that you can draw has shape. Not true, because the number 5 has shape. You can draw it. It's not an object. Why? Because it's not the number 5. And I'll get to that in a second. You'll see why. Okay, let's continue here. That means that deltas, he was talking about the delta, saying that it's a physical object, as explained by me, must have shape according to you because you were able to follow my instructions and draw it. Yeah, I can draw a delta, the letter delta. Hey, all I see is just a symbol. You say, is that an object? Not because I can draw it, but because that thing, whatever that little d there is, has shape, and I can point to that. You call that a delta? Yeah, whatever that is, it's an object because it has shape. So if you say delta has shape, yeah, but that delta has nothing to do with the delta you explained. Because you said that the delta is some kind of change between two frames and la 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 la, and that's not an object. If you're going to represent it with a delta, with that symbol, and you're going to call that symbol delta, that is an object because it has shape, whatever that thing is. Like a number 5 is an object. But see, if you say, well, the 5 represents blah, 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 no, then it's, all bets are off. That thing that you see in front of you, that is an object. You call it 5, you call it X, you want to call it tree, you can call it whatever you want. Okay, and you say, well, you drew a 5, so is 5 an object? No, that thing that has shape is an object, not the 5. The 5 is something else. And let me show you why. Okay, very easy to destroy this fellow's insinuation there. Okay, his argument. Here we have it. This is his question. He says, we now have a more clear, this is another fellow, but along the same lines. I need to show this first. We now have a more clear, revised definition of object. Object, that which you can draw or imagine. Okay? If you don't think that definition is more clear, go and reread. And he says, rope hypothesis, appendix 5, not all objects are visible or tangible. Well, the first thing we're going to mention is that what an object is not. Okay? An object is not that which you can point to, and an object is not that which you can draw. What was the definition? You got to stick with the definition. You can't move a single letter of the definition. The definition is that which has shape. Now, if it has shape, whatever it is, if it has shape, you can point to it and you can draw it. And if you can draw it, you certainly can point to it. It doesn't work in the opposite direction. It's not because, I point to something that is an object. It especially depends on the concept that represents. And let me show you why. I'll give you an example now that shows you why these people have mental problems. They don't understand this, okay? What do you see there at the bottom? Well, someone would say that's a 6. Is that a 6? Or is that an object?
And you say, well, it's the same thing because that has shape, it's a 6, so obviously it's an object. Well, let me modify it a little bit just so that, that we're on the same wavelength, okay? Here it is, okay? Let's modify it a little bit. Is that a 6? It's the same object, it's just lying down. It's in a different position. Is that a 6? Maybe it's a 9, I mean, I don't know. And so the question is, the object is the shape. I don't care what situation it is. You can put it upside down if you want. It's still an object because it has shape. Is that a 6? And the answer is no, that's not a 6. But I thought you said it was a 6, right? And yeah, it's a 6 over here, okay? But not over there because you're reading too much into it. We're looking at the object that has shape, and if you want to call it a 6, an X, a tree, a rock, you can call it whatever you want. But that doesn't mean that that represents what we understand by the word 6, which is a number, which is counting, which is a verb, which is a process. So these two are separate things, different things. Okay, and with that, I'll see you next time, and hopefully I feel better next time.